Let's see about timers in RSLogix 500. So here we are having three types of timer: on delay timer, off delay timer, retentive on delay timer, right? So timer on delay, it is used to turn on an output after some time, right? And off delay timer is used to give the delay to turn off the output, and retentive on delay timer is used to hold the accumulator value even though the input condition goes off, and we should use the reset coil for that. So all the four blocks over here are the output instructions, right? So timer on delay and off delay, retentive and even reset, all are output instruction. So before getting into the software, I'll show you some timer specification. So totally we can use 256 timers in single program, right? And certain parameters we need to know before getting into the timer block. So the first one is the timer number. Can you see the timer on delay block over here? This is T4:0. So this is the timer number. If you see, what is that first T? It is a file type. So in a data file, T means it is a file type. We get to know from that it is a timer address. And 4 is a file number. The 4 followed by T is a file number, right? And the colon is a separator, and 2 is the exact timer number. If you can start with a T4:0 to T4:255. So totally we are having 256 timer. What is the next timer parameter is time base. How we are going to count, whether it is in a second or millisecond. So we have an option to select the time base also. If the time base is 1, it is mean that it is 1 second. Like how it is counting means 0, 1, 2, 3, like that it will go. In a second format it will count. And the third parameter we are having here is preset. So preset is a duration. How long we need to hold the output, or how long after we need to turn off the output if it is a off delay timer. So preset is a time interval. How many seconds or how many minutes, depends upon that we need to give the preset value. Here in the block it is 20. So from this we get to know for this particular timer the time duration is, or the time interval is 20 seconds. And accumulator value. So accumulator is the place where you are going to store the running value. And we are having enable bit. So we are having 3 bits. One is enable bit, done bit, another one is timer timing bit. Here you can see enable bit, timer timing bit, done bit. So enable bit is like a rung condition. Whenever your rung goes on, enable bit will be on. Done bit will be like whenever your 20 seconds has happened, after your timer has done its work, timer done bit will be on. Timer timing bit will be on when your accumulator value is running. So you can find in a 16-bit file, done bit is at the 13th bit, TT bit at 14th, and enable bit at the 15th. Even accumulator value and preset value will take 16 bits to store the value. So let's see how to use this in a software. So in this we are having one input and one output. This is sensor 1 and this is motor 1. So whenever I am turning on a sensor, maybe a sensor is giving a signal, motor should turn on after 10 seconds. So the condition is whenever sensor is giving a signal, motor should turn on after 10 seconds. So we are going to delay the on operation of your motor. So obviously you should use the timer on delay, right? So you can, in a timer bar counter option, you can find TON. This is timer on delay. So just click on that. It will be at the right hand side since it is a output instruction. So it is asking a question mark. We need to give the timer number. I'm going to start with 0. So to T4:0 I have given here. And preset I'm going to give 10. Okay. So now after 10 seconds the motor should turn on. So I'm going to use the done bit of our timer. So just take one normally open contact and give the done bit address. So what is the done bit address means? You can go for timer number first, T4:0 dn. Slash dn means it is a done bit. Slash tt is it will be the timer timing bit. En means it will be the enable bit. You can get reference from in the timer block also. Here you can see enable bit T4:0 slash en tt dn. Right. So let's check for error. Go for online. So now sensor is giving a signal. So timer started running. Can you see the accumulator value is running and timer enable bit is on now because run condition is true. So once 10 seconds happened, once the accumulator value reached the preset value, done bit is on. So motor is also on because we have used the done bit. So if you turn off, enable bit will also off, done bit will also off. I'm again turning on. Your enable bit is on, accumulator value is on. Suppose if it is turned off, immediately sensor is not giving a signal means your timer is reset automatically. Your enable bit is also off and your accumulator value is also back to 0. So to make the timer to continuously on, we need to make the run condition true always. The run condition need to be true, then only the timer will be running continuously. If you turn off, it will go off. So this is the working of on delay timer. Let me see the remaining 2 bits also. So I'm going to take 2 more runs and here I'm going to have timer enable bit and here I'm going to have timer TT bit with one output. So let's have one more output here. Let it be as motor 2. Change the address first. Yeah, motor 2 and I'm going to have one more output and naming this as motor 3. So this is the enable bit, right? So you can drag it and place it here and just change instead of dn, just type en. Same, drag it and place it over here and instead of en type tt. So now we have connected all the 3 bits. Go for online and check how it is working. So enable bit will be on until your condition getting false. Whenever your sensor is on, a run condition will be true, so enable bit will be on. Timer timing bit will be on once the accumulator value is started running from 1 to 10. Done bit will be on once your timer has done its work. Just go for online. Just turn on your toggle bit. Yeah. Now enable bit and timer timing bit is on. Just watch the timer timing bit. It will go off after 10 seconds. Yeah. So it went off and your done bit is on. So motor 1 is in a on condition. So if you turn off, automatically your accumulator value go back to 0. Again you can start from the beginning. There is no reset coil to use for this. Because whenever the input condition is going false, your accumulator value is going back to 0. So a timer is reset automatically. So this is how you need to work with the on delay timer. Let's check out for off delay timer. So instead of on delay timer, we are going to turn on a output and after some time it should go off. Even though the input condition goes off, after some time output need to off. Just remove these 2 runs. So here also I am going to use the same address and preset value as 10. Check for error, go for download. Turn on a sensor which will make your motor 1 to go on immediately. Right? So if you turn off this, motor will not off immediately. It will take 10 seconds to go off. like this. It will go off. Yes. So motor is off after 10 seconds. So this is a way to turn off a motor after 10 seconds by using a off delay timer. I'm doing it again. So your timer is at 0 only. Your accumulator value is 0 only. Whenever you are going to turn off the sensor, it will start counting. This is the working of off delay timer. Yes. So same as on delay, here also we are having timer, timing bit, enable bit and all. So let's check how it is working here. So just give the address EN and this gonna be the TT. And the output check out now. So done bit is different here. So in on delay timer it will be turn on after 10 seconds. It will turn on immediately in off delay timer. See. So it is turning on immediately once you turn on a sensor. But timer timing bit is off because your accumulator value is not yet started running. So if you turn off, enable bit will be off because run condition goes false. Timer timing bit is on because your timer is running. Enable done bit is also on. So once the 10 second happen, that is accumulator value equals the preset, both done bit and TT bit will go off. Right? So this is how you need to use the timer functions. Right? So we have seen on delay and off delay.